Hi, I am Arib. You are watching my YouTube channel. History of Scada System. In the early years when electric power system began developing, electricity generation plants were only associated with their respective local loads. If anything failed in the whole linearly connected system, which could include subsystems like generating plant, power lines, connection, and then the lights would be out. Customers had not yet adapted to depend on electricity. Outages, whether routine or emergency, were taken as a matter of course. As reliance on electricity grew, so did the need to find ways to improve reliability. Generating station and power lines were interconnected to provide redundancy. As the system expanded and began to scale out in size, it became harder to manage. Solutions were needed to face the challenges of controlling equipment over long distances. To overcome this, operating personnel were often stationed at the important points in this grid system so that they could monitor and quickly respond to any problems that might arise due to any fault or failure. They would communicate with central electricity dispatchers, often employing telephone, to keep them informed about the condition of the system. Many manufacturing floors, remote sites, and industrial plants relied on personnel to monitor equipment and manually control through mechanical push-button and analog dials. As the demand for reliable electricity grew even more, and as labor became a significant part of the cost of providing electricity, technologies such as Scada were developed which allow remote monitoring and control of the system's key parameters. What is Scada? Scada stands for Supervisory Control and Data Acquisition. Scada is a system of different hardware and software elements that come together to enable a plant or facility operator to supervise control processes. Supervisory control is a general term for a high level of overall control of many individual controllers or multiple control loops. It gives the operations supervisor an overview of the plant process and permits integration of operation between low-level controllers. Data acquisition is the process of sampling signals by measuring a physical property of the real world in the form of signals and converting it from analog waveform into digital numeric values so that it can be processed by computing machines. Supervision. Computers process the data and let personnel in charge to oversee and direct the status of the power system using the acquired data. Personnel in charge were often operators and engineers who monitor the information remotely or locally. Now the master station is tasked to supervise most of the system. Control. Control in Scada refers to sending command messages to a device to operate the instrumentation and control system, I&C, and power system device. Conventionally, Scada relies on human managers to initiate command from an operator console on the master computer. Field personnel can also control machines using front panels. Data collection. Instead of collecting data, filling data sheets compiles information in real time. Scada gathers data from hundreds or even thousands of sensors at a given time. It also generates backlogs for later analysis, data presentation. Scada interacts with human operators through workstation computers that deploy the human-machine interface, HMI. The master station presents a widespread view of the whole system and alerts the operator by visual display or alarm sound. Components and its function. Scada system comprises of the following components: sensors. Field instruments are an array of transmitters, monitors and sensors. Sensors are the transducers which detect changes in physical quantity. This sensor can be analog or digital, but ultimately their purpose is the same. Sensors help its users to measure and collect data from various locations. The more complex a system, the more sensors we may need in place. Conversion units. Sensors are responsible for collecting data, but we also need something to be able to receive and interpret the data. This is where the conversion unit comes in. Conversion units are the computerized units deployed at a specific location in the field. These are connected to sensors. They convert the information they receive into digital format, which is then sent to the centralized system to display. The two most common types of conversion units used in a Scada system are PLCs and RTUs. How do we determine which unit we need? That depends on what our specification is. Programmable logic controllers, PLCs. Programmable logic controllers are good for situations where we want more localized control. The programmable logic controller is an industrial digital computer designed for output arrangements and multiple inputs. PLC is used sometimes in place of other conversion units due to their versatility, flexibility, affordability, and configuration. However, one may need good programming skills to make the most out of it. Remote Terminal Units, RTU. Remote terminal units are microprocessor-controlled electronic devices. Their objective is to interface Scada system with a sensor or whatever objects the RTU is connected through wireless communication. Therefore, they are considered good for functions covering a broad area geographically. The above conversion units assist as local collection points for gathering information from sensors and delivering commands to control and protection relays. Communication network. Scada system cannot exist without a properly designed communication network system. All the Scada system aspect relies solely on the communication network. It provides a channel for the flow of data between the supervisory control, the data acquisition units, and any controller that is connected to the system. The main function of a Scada system is to connect the conversion units with the Scada master station. The data can be transmitted through various communication platforms such as Ethernet, telephone line, power line carrier communication, optical fiber line, cellular, radio, satellite, Wi-Fi, microwave, or other wireless protocol. Most facilities have specialized integrated network connectivity field buses, wired or wireless, due to security reasons. Master unit. Master units are larger computer consoles that act as the central processing hub for the entire Scada system. The master units offer a human-machine interface to the system and automatically regulate the managed system based on the response of input created by sensors. The master unit is considered to be the supervisory computer system because they serve as the Scada system centralized processing unit. Although the units themselves are typically larger computer consoles, there are several other Scada components, such as software program and HMIs, which could be named under this category as well. Generally speaking, human-machine interface, HMI, is a user interface or dashboard that connects a person to a machine, system, or device. In a Scada system, it allows the operator to view and interact with collected and processed data. This like collecting data, creating maps, diagram, sending out notifications and making reports. Remote Communication Server, RCS. After processing and analyzing the data gathered in the Scada system, one needs a digitally and physically secure place to store this vast database. The Human-Computer Interface, HCI, or HMI, commonly requests data from a server responsible for data acquisition, a component of hardware that is used to connect software service to the conversion units out in field. The server makes data acquisition from these local units possible. Advantages of Scada. Scada systems are an extremely advantageous way to run and monitor processes. They are great for small applications, such as climate control. They can also be effectively used in large applications such as monitoring and controlling a nuclear power plant or mass transit system. Optimizing performance, Scada systems minimize errors by accurately measuring data and increasing the overall efficiency of the system, reliability and robustness. The specific development of Scada is performed within a well-established framework that enhances reliability and robustness where power requirement is crucial, maximize productivity. The specific development of Scada is performed within a well-established framework that enhances reliability and robustness where power is crucial. Improve quality, analyzes, and controls the quality of the produced electric profile using standard Scada functionality, reduce operating and maintenance costs. Less personnel and trips are required to monitor field gear in remote locations. This reduces maintenance and training costs. Integrate with business system. A Scada system can easily integrated with the business system, leading to increased production and profitability. Conclusion: Scada system can be implemented on a large scale in power systems so as to increase their performance, reliability and durability. Data acquisition and monitoring can be very convenient and accurate if power systems are upgraded to Scada. Now, electrical systems are extremely efficient and intelligent to monitor and control all of the involved operations and procedures, and it has become possible only because of technological advancements. So we can conclude that it's essential for the power sector to optimize their systems as per the requirements of the technical changes.